Hi there, my name is Isaac Oster, and in this video I'm going to talk about this HDA that I built. It is an auto atlas texture tool. So what you do is you just feed in the geometry path and then one of the textures that is assigned to that geometry, and set some export locations and some file formats and some file sizes, some texture resolutions, and then press this button and it will take all of the input maps and run through all of the ones that are consistent across all of the assets and do an automatic UV layout on them, and then bake out the textures and export the updated FBX. So why would you maybe want to do this? Every time you have a unique material in the game, it will require a specific draw call. And the draw calls are one of the primary drivers of performance issues. So if you can minimize the number of materials that you have on scene in any given moment, the more efficient the game will become. So it is pretty common to create assets like this for a game. This is something that some pieces I built for Call of Duty a while back, where you might have some kind of a base clothing, and in this case like a bulletproof vest or a backpack or something, and then you would just want to strap on a bunch of these little doodads so that whatever the specific loadout was for that character, it felt unique. But each one of these has their own set of textures, and everything is all in 0 to 1 UV space, so each one would require its own draw call, and that's just not really as performant as it could be. Another scenario where you might want to do this is if you have multiple materials on, say, a character, and as the character gets farther away from the camera, you may want to merge the materials on the LODs, the farther away versions of the geometry that you don't see up close. So you can make the materials cheaper. Maybe they become, rather than like double-sided, they become single-sided or whatever. So you can combine those kinds of material shader simplifications with reducing the overall draw calls, and it's just a win. So this is a fairly common thing to have to do in game dev, and I just thought it would be an interesting challenge to try to do it with Houdini. And I wrote a version of this tool a while back. You can find it on my website, isaacoster.com. But it was all done in Python and Maya, and it wasn't quite as smart as what this tool can do. So I just want to go through and talk about how I built it. All right, so the first challenge with this project is we're not really allowed to know how many assets the user is going to want to create an Atlas texture sheet for. So we've got to create a way for them to easily enter in however many pieces they want to combine. And to do that, I use what is called a multi-parm. So I'm just going to go ahead and get rid of those, and we'll slide the type properties over for the HDA. And so the way that you make a multi-parm is you just add a folder in. And then in the folder, under the folder type, you just set it to multi-parm, and then anything that you put inside of that folder will be presented in the UI like this right here. So under the import source files. So under import source files, I have 3 items. I've got a geometry file path, I've got a texture file path, and then I've got a separator just to kind of organize things a little bit. And one thing that's worth mentioning is when you have a multi-parm, if you give an item a name here, this is going to be the unique name that you refer to this specific UI element with downstream, and it'll automatically have this little number sign here, and whenever the user creates a new instance of this multi-parm, it'll basically just say 1, 2, 3, 4, 5, so that you get a way to refer to the specific geometry path or texture path or whatever the UI element happens to be. So we can easily refer to it later on just by calling the number. And the count starts at 1, not 0, so that's worth mentioning. So I'm just going to go ahead and we'll enter in some geometry. So hop over to asset 1, grab the geo, and we'll grab the texture associated, one of the textures associated with that geo. It doesn't matter which one you grab. The only implication of starting with one over the other is once the process is complete, it will assign whatever this suffix is to the geometry in the viewport, so you can preview the result. I'll go ahead and add a second asset here, and one of the textures associated with it, and a third asset, and the texture associated with that last set. So here everything is. That's not necessarily what we're seeing here because we need to run the code. So what it's going to do is once I've entered in the geometry and one associated texture with that geometry, and given it some information about where it's going to export the FBX and where it should put the new textures that it's going to bake out, as well as you can also do FBX versus OBJ or pick your choice of various image formats. Oh, and by the way that you make those little drop-down menus is you just throw a string in, and if you go to the menu tab and you basically turn on use menu, you can add whatever you want in here, and then those items will be available to your user as drop-down items there in the UI. So what we're going to do, I'm going to go and just kind of scoot this up a little bit so we can take a look at the node network. These nodes here, the geometry and the material assigned to the geometry, are going to have to be created procedurally based on how many items the user has input. So in this case, I've got 3, and then each time the code runs, it'll destroy whatever's in here and rebuild this part. The rest of the network is permanent. So the first thing we have is a merge node to bring all the geometry together. And then I have a UV layout node. Let me actually roll over to the UV view for just a second. So we've got the viewport. This is after they've been laid out. So initially it's going to look like this. This is all of the UVs for each asset in their original location. So you can see it's all overlapping and totally not usable in its current state. So we do a UV layout. A few of the options here. Let's see. Let me go ahead and unpin the HDA. Some of the, all of the stuff you can expose to the user if you want, but I wanted to avoid rotations because that'll bust the normal map behavior. And then stacking identical islands. One of my assets has a lot of these pieces. The wheel here has a lot of the sections of the wheel are all stacked up. So I wanted to make sure that that was preserved. And again, you can expose this if you want. I didn't think it was necessary to bloat the UI too much, but it's certainly not that big of a deal. And then we have a new Atlas material, and then we have our little output node to complete that part of the chain. And then we have our maps baker. So the maps baker takes 2 inputs. The first one is the original meshes with their unique UVs, and then that goes into the high poly slot. And then into the low poly slot, we have our updated UV layout. So everything is all nice and organized. And this has a couple of important things. I'm going to go ahead and set this, the output directory, according to what's in the UI. This is also going to be sourced from the UI. And then I want to enable the diffuse map and select nearest surface. So that's going to be how it finds where it is going to be baking from, and because the geometry is identical, the nearest surface will be the best result for that. And then the rest of these things, I don't even think I messed with. So, and then over here in the FBX export ROPNet, it's just a simple export FBX where I set the path, and then just kind of export that once it's all done. And it takes as its input, basically it just knows to kind of look to find where it lives, and then it just looks for the output there, and it'll go ahead and bake that out. So what we're spitting out here is the FBX with the UVs laid out, and it also has a material assigned to it, so that we're sort of ditching all of the any legacy materials that might still be assigned. We just kind of give it a nice clean one. We call it Atlas Mat, and then spit it out. And once you get into the next step in your process, you can rename that material to anything you want or assign a new material, and that'll be that. So that's the general structure. Now I'm going to sort of walk you through what the Python looks like that's happening under the scenes. It sort of sets up these assets and then figures out what's going on with the textures, and then pipes them in to the materials one at a time, and then bakes out the resulting Atlas textures. So we have a button here at the bottom of the UI. Once the user has entered in all of the relevant information, that will kick the whole thing off. And if you want a more detailed explanation of how this is all set up, I recommend IndiePixel's Intro to Python in Houdini YouTube series. It's excellent. But basically, this section of the code refers to the HDA. And then this section refers to the scripts module, and then process assets with the quargs argument, that refers to this function here that I wrote inside our Python module. So the quargs argument here is effectively a dictionary that has some important data about the HDA, and the only thing that we're really worried about is the node. So if I just say HDA node, and then I look for the node key in the quargs dictionary, then it's going to return back a way that I can access the HDA node. And then once I've got the HDA node, I can start pathing down to the Geo node, which is the next one down here. This is our generate Atlas UVs bakes. That's this is the HDA, this is the Geo node. And then the merge node here is this merge imported geo. And the reason I want to start there is every time I run through this process, I need to identify everything that is upstream from my merge node and delete it. So that's what this code here does. We're just going to go ahead and use this input ancestors function on the merge node, and it's going to return everything that is feeding into it, and the children of those things, and if there were more generations, those nodes as well. And then we can just iterate over every node in that list and destroy them. So the next thing I need to know is how many objects has my user input, and I'm storing that data in this variable here called index. So to get it, I've got this parameter called import source files underscore index. And let me just hop up to the top of the HDA. And if you just mouse over it, this is right here, this is the parameter I'm looking at, you can see it is called import source files underscore index. I didn't have to look too hard to find that. And then this eval function just returns whatever the value happens to be. So in this case, index evaluates to 3 because that's what's living inside of that parameter. So I want to make sure that my index is greater than 1 because I need at least 2 assets to properly atlas. Otherwise, I'm probably just spitting out a clone or maybe a different UV layout depending on what Houdini decides to do with the UVs. So once I've confirmed that I've got more than one item entered, I need to go through and start looking at the textures and making some decisions about those textures. So I'm making some assumptions about how these assets are set up. I assume there's a piece of geometry, and it has a material assigned to it, and then into that material several textures are plugged in. And the other assumption that I'm making is that all of the textures for the asset have the same prefix, essentially. Whatever made sense to call the thing, all of the textures are going to have that same thing at the front, and then each one is going to have a unique texture type at the end of it, separated by an underscore. This is usually how I've seen it done, so I think it's a safe assumption. But so here we've got the color, the normal, the roughness, the metalness, and the height for this asset. So then I'm going to go and I'm going to look at the next one, and I'm going to say, yes, okay, so we've got that same situation. I'm going to find all the textures that start with this name, wherever they happen to be, and then I'm going to take a note of what the suffixes are for each of those, because it's not unusual to find a scenario where you have some assets that might have, for instance, an emissive map where others don't. So I want to make sure that I am not trying to go and grab emissive textures that don't necessarily exist, and so we've got to set up a little bit of logic to take care of that. So we're going to do some checking here and some confirming that everything exists, and if something doesn't exist, we'll warn the user that we're going to skip that particular texture set. So I'm going to grab my texture path from the HDA, and that's basically going to be this right here. So it's going to give me the name of the texture and then the full path to it. So I need to, it's actually going to get truncated initially with this this $hip alias, but I can use OS, this very, very useful module OS, to split this data into the file path and then the file name. So to show you what that looks like, I'm going to go ahead and uncomment this line. It will go ahead and print the file name out. So let me hit apply. And here we can see file name equals gun low updated UVs blah 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 gun base color TGA. So we get the full file name. Don't worry about this emissive message yet. That will make sense very shortly. So I'll go ahead and comment that out. So that's giving us our file name. So we basically have access to the raw file name, but we need to split it up a little bit more because we've got to figure out what's the map associated with it and what's the name without the map attached to it. And by map, I mean base color, normal, metalness, whatever. So I'm going to go ahead and take the file name, and I'm going to use the split method with an underscore as the argument, and I'm going to take the last thing in the list that this returns. So if we look again at this, if I'm splitting this name up by underscore, the last thing in that list is going to be base color. So that's going to give us the file name map. And then file name generic is going to be that same file name that we got from our OS operation up here, except I'm going to split it at the underscore and the file name map, which was what we just determined, and then I'm going to take the first item in that list. So that'll give me my file name generic, and to show you what that looks like, I will go ahead and uncomment the file name generic. We'll hit apply, run the code, and here are the generic file names. So we basically just popped off the underscore basecolor.tga. All right, so now what I need to do is go through the path and look for all of the files that start with the same file name, our file name generic here. And again, I'm making an assumption with my assets that this part is all going to be the same. Asset 02, asset 02, asset 02. All of the textures that are associated with the asset are going to have the same generic file name, and it's only going to be the file type or the suffix that is that's unique among the textures. So I'm going to go through the directory using this OS lister and feed it the path, and then I'm going to look at every single file in that directory. And if the file starts with my generic file name, I'm going to go ahead and append it to my texture list, which is defined up here. It's just an empty list at this point, but by the time I get down to texture list, it's going to have every single texture in it. And we can go ahead and uncomment that and take a look at what the textures are. So we'll hit apply. We'll run the code. And here you can see all of the textures that are associated with each material set effectively in each directory. So I'm just looking for any texture, any file really, that starts with whatever my generic name was, which is anything on this side of that last underscore. So what I can do now that I have that list is I can go through and make sure that I have the same number of files, specifically the same number of suffixes per material set. All right, so the suffix list is going to be I'm going to use this later on, and this will be the final list of unique suffixes that I'm going to be iterating over. And I've got a suffix test list that I'm going to be using to confirm that I've got the same number of suffixes for each texture set. So we have a little for loop here that's going to iterate over each texture in texture list, which are all of these. And then it is going to, let me scoot this up just a little bit, it's going to append to the empty suffix test list the result of a split operation where we're basically splitting each name by the underscore, and then we're grabbing the last thing that is in that list. So in this case it would be metallic, height, base color, whatever. And then all of those things are getting dropped into suffix test list. So let's go ahead and take a look at what is included in suffix test list here. And as expected, this is what it looks like, right? So base color, emissive, height, metallic, normal, blah, 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 all the way down for everything. And then what I need to do is I need to confirm that I have the same number of, let's say in this case, there are however many base colors there are, is the same number of assets I have plugged in up here. Because if I have the emissive, where are we? This only occurs one time, which means, and we have 3 items, which means I need to go ahead and just skip the emissive, and I'm going to let the user know that emissive is not on the table for our little atlas operation here. So that's going to happen right here. We're going to say, oh, I don't actually need this. Let me get rid of it. So for suffix and suffix test list, if suffix test list.count does not equal index, we're going to go ahead and print it. Print that we're not, that the suffix that we found is not available for all materials, so we're going to skip it. Otherwise, go ahead and grab that suffix, assuming there are the same number of instances of that suffix as there are the index, which is our number of assets. We're going to go ahead and grab that suffix and append it to our suffix list. So we can go ahead and just print our suffix list. And let's see, I think I've got another print here. We can comment that one out. So let's apply that, give it a print, and see where we land. Got a little bit of a problem here. Oh, I grabbed the wrong print there. Got a little bit too excited. So here's our suffix list: base color, height, metallic, normal, and roughness. So this list represents all of the, whatever the plural of suffixes or suffi or whatever, that are common to all of the assets that we have imported. So this is going to be the foundation of the next part in this process. All right, so now that I have analyzed the textures associated with the assets imported by the user, I'm going to go ahead and need to rebuild this part of the node structure. So at this point, all of these are gone, and I need to rebuild them. So the first thing I need is the geopath, and let me actually just hop over to my HDA and lock that for a moment. So the geopath is going to be this. Each asset gets a unique geopath, and the way that I refer to the geopath is by going to the HDA node.parm, and then I type in source geometry path, and then this is very important. These things here, they don't start their count at 0, they start at 1. So we can see the first one is source geo path 1, and then this one is going to be source geometry path 2, and this is source geometry path 3. So because I'm using a for loop, where my range is the index, that means I'm starting my count at 0. So if I would like to use I need to make sure that I add 1 to it so that I can refer to the appropriate source geometry path parameter. And then this eval function will just return whatever the user has entered into there. So once I've got my geopath, I can create my file node. So let me jump in here, and I'll go ahead and unpin that. We'll select the file. And into the file, we need to specify what the geometry path is going to be. So first I create a file node, and then into that file node, I am going to set the file parameter to geopath. So this geopath is unique for each time I run through the for loop, and it speaks to a different set of input assets from the user. So once I have the file node set up, I can build my material. So I create a quick material here, and if you're curious about how to figure out what the name of it is, you can just come over to this little information, and then it'll tell you exactly what the name is if you want to create it using this create node. So geo node is our parent layer here, and then if I want to create something inside that, I just need to go ahead and give it a name of the node, and then I'm going to go ahead and set the input of my material to the file node. So I basically just plug this into that. And then I need to go ahead and merge the material into this merge node. So everything, the merge node down, that's all permanent. That lives forever. It's just these assets here that get destroyed. So what I've effectively done with this little snippet of code here is I create for each asset entered in by the user, I create a file node and then a material. I hook them up. I plug in the appropriate path to the file node, and then all that stuff comes in here to merge imported geo. So once my textures are analyzed and my node network is set up, I am ready to move forward with the baking process. And the way it's going to work is I'm going to basically find for each suffix here in my suffix list, I'm going to find all of my textures that correspond to that suffix, and I'm going to plug each one into the materials, and then I'm going to bake. And then I'm going to move to the next one, height. I'm going to find all the textures that correspond with that suffix. I'm going to plug them in, and I'm going to bake. And then so on and so forth until I've moved through this entire list. So because I am iterating basically over two lists, we've got the suffix list, and then we've got the list of materials in the scene. I'm going to use a nested for loop to do that. So on the outside, we're going to have the suffix list. And then on the inside, we're using index, and I'm going to use index to speak to each material here. So the first thing we need to do is basically rebuild our texture path without the suffix. So we're going to kind of go through that same process that we went through before, where we start off with the texture path sourced from the HDA input. And then we have the path and file name. We'll grab the file name map, and then which is going to be basically the suffix. And then we will find the file name generic by removing the suffix. So once that's done, we need to do something a little bit different. Let me go ahead and throw the X on there. I want to take that generic file name, I want to append it to the path with a /, and then I want to go ahead and add my suffix, whichever suffix I happen to be on, to that path. So whatever it is, it's going to be basically the file path, and then I'm just appending the whatever the active suffix is. And then once that's done, I'm going to go ahead and grab my material node J. Again, J is the interior one, so this in this case is going to be 1, 2, and 3, or I guess 0, 1, and 2. I forget exactly how that's set up, but I'll be able to speak to each material individually, and into the base color texture, I will be able to set that value of that parameter to texture path. So once that's done, I have this new function here that we're about to look at, which is called Bake Atlas Textures, and it takes the HDA node, the geo node, geopath, whatever the current suffix is, and then also whatever the iteration is for the current suffix. And we'll be using that for one specific little feature in this Bake Atlas Textures function, which we will discuss now. All right, so first of all, apologies, I didn't actually need the geopath, but I do need the rest of these things. So we'll go ahead and talk about how they are used and what else we gather to make this work. So the first thing I need is the image format. The user gets to pick whatever image format they want, so I need to make sure that I can grab that information. And then what I'm going to do is I'm actually going to pop the .tga or the dot whatever happens to be off of suffix. If we look at the suffix list, we can see here that it actually, they still have their file formats, their input file formats attached to them. Doesn't really matter. It doesn't break anything before this moment, but at this point I need to go ahead and remove that and apply whatever it is that the user has decided that they would like to have. So I need to grab that information and store it here in this image format variable. And then this suffix here, I'm basically just making a new version of suffix where I've split the suffix string at the dot, and I'm just keeping the front of it. So that is effectively removing the existing input file format. So then I'm going to go ahead and assemble my output path, which is going to start with my, actually that's just going to be sourced directly from the HDA parameter, the texture export location. And then so long as that variable, it doesn't evaluate to nothing, we're going to go ahead and move forward. And if the user doesn't have anything in their output path, I'm going to just ping them and let them know they need to go ahead and enter a location for us to save these files. So we're going to go ahead and build our output path variable. We're going to start with the output path, which again is coming from where we are going to save our stuff. And then I just have this in here just to make sure I don't override anything that might already be there. Atlas Bake 01, that's my little unique string. This is something I could certainly expose to the user, but whatever. And then plus suffix. So again, suffix, we've pulled the .tja off, and now it just says base color, whatever. And then I'm going to go ahead and add a dot and then the image format. So this is going to be my full output path. My bake node is going to be, let me go ahead and just navigate over to it. So this is the maps baker here. And inside the maps baker, I'm going to basically just create a way to refer to it. And then I'm going to set the output file to the output path. We can click on it. Let me unpin the HDA. So our output directory here, if I mouse over, you can see that just says S output file. So we're going to set the output directory to our output path. And then if you just want to, basically this is the button that you push, and if you want to essentially push a button that exists in a UI, you just say what the parameter name is, and then the function is going to be .pressButton. It could not be easier. Some things are just really, really nicely done here. And what I want is for whatever the first iteration is, I want that to be what I assign to the material at the end of the process. So basically, like once you're done baking, we will have generated a bunch of different maps that could potentially be applied here. And I'm assuming, again, this is something I mentioned I think a little bit earlier on, that the user has selected as the first textures their base color, whatever that happens to be, the albedo or however they named it. That's oftentimes the first thing in the texture list. So that's what I'm going to go ahead and assign to the final product here in this new Atlas mat. So we should be able to find that Atlas mat here at some point. But that's actually down here. So if I am on my first pass through, I'm going to run the update Atlas mat function. I'm going to feed it the geo node and the output path, which is basically, again, output path is my and for the first time through, it will be whatever atlas map I bake out using whatever the users have input in. So oftentimes that's going to be the base color. So the idea is if I'm on the first one, I just want to throw the base color on for the final result, just so, because otherwise it's going to pick like whatever the last one happened to be, which is like height or something random. And that's not really going to do anybody any good. So that's what I need the iteration for. But before we get down there, let's see, we've got our bake node parameter. We set the output file, we bake everything, and then I export the FBX every time. That's probably, it would be better to actually remove this. Maybe I could put this code down here so that it only gets run once. The FBX is not going to change. Let me go ahead and just update that. There's no reason to do something 3 times when doing it once will be just fine. So we'll go ahead and call that good. But yeah, so we export the FBX, we go ahead and grab the export location, and there's a little bit of a trick here with FBX exports. You've got to drop a ROPNet node, and then inside the ROPNet you will find the film box. So this is the output file that we need to set inside the film box, and you can see I basically create a reference to my film box node, and then I set the output to my FBX export path, which is sourced here from the HDA UI. That's an awful lot of acronyms. Okay, let's see. So then once we're through that process, I'm just going to go ahead and, so I've got this output 0. Let me hop back over. Oh, one other thing that's worth mentioning, the ROPNet will by default, I think, just look to see where it's at, and if it can find an output node, that's what it'll export. So what we're trying to export here is the low poly geometry, consolidate these a little bit, that has the correct material assigned, my little atlas mat, and then it just spits it out. So these are the atlas UVs with the atlas material, and then yeah, that's what it'll save out as its FBX. So that is all handled with this code, and then this code, and then this last little snippet here will go ahead and just turn on the render flag and the display flag for our output, so that what we get at the end of that process is something that is informative to the user and hopefully gives them a good idea of what it is that they have created. And if they want to double check, they can open the the file in Maya or whatever the application happens to be, and apply the textures, and everything will be correctly atlased. So here's a little example of what that looks like. This is the source textures for this asset right here, and then after our atlas pass, we have this. So these are the same size, they're both 2K, and you can see this area here has been reduced to this size. And also another thing I didn't mention about the UV process is it will maintain a consistent texel density, so that it's sort of driven by the world space dimensions of these objects. So the actual size of the islands here in the atlas textures is determined by the relative size of the assets. So there you go. That is a fairly thorough walkthrough of this Auto Atlas baking tool. I would love to answer any questions if anybody out there is curious about something that I didn't cover. And thank you for watching. And yeah, take care.